Hi guys, over the next few videos, we're going to talk about techniques that are used to investigate infectious diseases and outbreaks of diseases. In addition to a couple of videos that I've made, I'm going to be asking you to watch a video about John Snow's investigation of the causes of cholera in mid-19th century London. This is considered really the origin, one of the origin stories of epidemiology, one of the first great epidemiological investigations. So I'm really asking you to watch that video. Let me pull up our slides. First, I want to start with some vocabulary that we use. And we're talking about mostly infectious diseases, which is diseases which are caused by some infectious agent. It could be a virus, it could be a bacteria, it could be a parasite, but where there's a thing which is causing our disease. You do sometimes use this vocabulary even for things like heart disease or lung cancer or the lung disease that was lung infections that were caused by vaping that were a big issue about last summer. But mostly we're going to be talking about these diseases with an infectious agent. So I want to start with a little bit of vocabulary. We start by saying there's often a level of disease that's just bouncing around in the community. It's just what we expect. We might wish it weren't there, but it's important to know what the baseline level is. That's called the endemic level of a disease, because usually we don't investigate what's going on until the level of disease rises above that endemic level. Now, sometimes there are no cases of the disease, and we would want to, and we want to investigate anytime we see one. For example, measles. Measles was endemic in the United States until 2000, meaning that there were just cases of it bouncing around. It's a contagious disease, so when there's cases, they tend to spread to other people, and they would only investigate what was going on when cases of measles grew to more than they would expect. Since 2000, measles has not been bouncing around in the United States. So the measles outbreaks that we've had have all been caused by some case that came from outside the country, and even one or two cases of the measles merit investigation because it is not endemic in the US. An epidemic refers to what happens when the number of cases rises above the endemic level in a certain community or area. Sorry about that. I just tapped I'm just going to back up and keep going. So you just got a brief preview of coming slides. So epidemic is when the number of cases rises above the endemic level, and an outbreak means something a lot like an epidemic, but an outbreak is generally smaller and more controlled, not controlled, but it happens in some very limited geographical area. Outbreaks of contagious diseases, that is, diseases that can spread from person to person, can often turn into epidemics if they aren't caught and kept under control. So epidemic tends to be kind of a larger word than outbreak. And as you may know, a pandemic refers to an epidemic that has spread across multiple continents, that's worldwide. So let's just look at an example of this. These are deaths due to flu and pneumonia. Pneumonia deaths are largely attributed to flu, which we track. Flu has a seasonal pattern. It rises, you can see this is around week 50. So this is December, January. That's when flu deaths rise and falls again through the summer. These black bars are showing the expected level, the seasonal baseline. Those are the endemic levels of flu that we know we have in this country. The red are the actual number of deaths, and you can see that 2017 to 18 was a very bad flu year. We had a flu epidemic that year. It rose well above the endemic threshold. There was a minor epidemic in 2016 to 2017. This past year, 2019, we were also seeing a flu epidemic, although there is some concern about by the time we got into, no, they don't, sorry, I'm looking at the dates here. These are not yet COVID cases. These really are flu. So there are endemic levels. When it rises above that, we have an epidemic, an outbreak that merits careful investigation. There's no particular term for when your cases are a little below the endemic level. You're doing well? So, what types of infectious disease outbreaks do we have? Well, infectious diseases are not necessarily diseases that spread person to person. Down at the bottom, propagative, those are diseases that are spreading in outbreaks that are spreading from person to person, like measles, like the flu, like coronavirus. But we also have common source outbreaks where many people are getting sick from some contaminated source, often, although not always, food poisoning. And food poisoning really is, that is contaminated food of some source, really is the most common type of infectious disease outbreak. When we're talking about common source outbreaks, sometimes it's a point source. There was this single batch of bad food, sometimes it can be a food handler who is infected with something, who exposes a large number of people in a short period of time, causing a sudden outbreak that then all goes away. So the bad chicken salad that we talked about on the very first day of class at camp, that will be a point source outbreak. You can also have continuous common cause outbreaks where there's some source of contamination that's ongoing, that's making people sick until the source is removed, either because it was identified or honestly out of luck. This could be contaminated groundwater or environmental pollutions. You may remember the E. coli contamination in romaine lettuce in 2019. So those are some of the sorts of outbreaks that people investigated. And then, as I said, there's also our contagious diseases or propagative diseases that spread from person to person. And when you're looking at a disease outbreak, one thing that people do is they make so-called epidemic curves, where each box on this is a new case of the disease. So these are showing incidence rates, new cases. They're marked at the time when the person got sick, not necessarily when they first came to the attention of the health community. This is a case of hepatitis A, which is an acute disease. It's often caused by poor hygiene in food handling. And the incubation period is very long. It's 14 to 28 days. So you can be exposed and you won't get sick until 2 to 4 days later. It can spread person to person, but it fairly rarely does. So what happened here is they believe there's this one case who was a food handler at a restaurant who presumably wasn't maintaining good hygiene, wasn't washing his hands well. And then we saw this large number of cases. And the assumption is that all or almost all of these cases were infected by this one person because the incubation period is so long. These cases couldn't be infected by one another. There wouldn't have been enough time for it to spread. So these cases were infected by this person. It may be that these few gray cases were secondary cases infected by one of these people, but for the most part, this was a point source outbreak. This, by contrast, is the E. coli outbreak in romaine lettuce, and you can see that there were cases stretching from late September, October, November, December. Lettuce doesn't stay good for that long. This was not one contaminated batch of lettuce. This would be some contamination in the way lettuce was being produced and packaged. There'll be a few cases earlier. It picked up, and until they figured out what was going on, the contamination in the water, I believe, that was used as the lettuce, people were continuing to get sick. So this was a continuous common source. Finally, this, by contrast, is a classic example of a propagative outbreak of measles, where there were a couple of cases of measles. It started to pick up and then drops off, because these people probably all got sick from one of these, and then it dropped off. But then there was a second wave. These people would all have gotten sick from some of the people in this group. So you had this wave of people all getting sick. Remember, each case here is a new case of measles. This is not the total number of people sick. This is new cases. This is incidents. So you have this group that would have all gotten infected from this group, and then you saw a drop off a number of cases. Yay, right? Not so fast. This group had been infecting more people. There is an incubation period. So the people who got sick from this group didn't start getting sick until about a week and a half later. And then you have this much larger wave because more sick people infect more people. So you get a larger group. And then as that drops off, still another larger one. Now, in this case, they got it under control. If they hadn't, what you would see was these cases merging until you would no longer have this rise and fall pattern. You would just have a larger and larger group, and you could no longer really identify were people infected in the first wave, the second wave, the third wave. A graph like this could be useful to help you figure out the incubation period. How long does it take to get sick after you're exposed? And other similar numbers that people would want to calculate. So those are some of the things that people look at when they're looking at outbreaks and the types of outbreaks that they've got. Now, let's say you've got an outbreak and you want to investigate what led to it, particularly in these sort of in these point source or common source cases. Just what's going on here. Let's talk about a specific one. It was a community outbreak of botulism, which is caused by contaminated food in Indiana. This was in 1983. So 28 people were hospitalized due to botulism. That is definitely an outbreak that is much larger in a short period of time than the number of cases of botulism that you would expect. So that's what you know. You have these 28 hospitalized people. What would you do to try to identify the source of the contamination? Give me your thoughts on the form. Okay, welcome back. So what's key to this is you certainly want to talk to the sick people. What were they eating? But you also need to talk to healthy people because it may be that the sick people, many of them were eating, I don't know, chicken. But if chicken is very popular and if lots of healthy people were eating it too, then it probably wasn't the source of the outbreak. So you need to do a case control study. And case control studies really are, well, the bread and butter of food poisoning outbreak investigations. So you need to know what is it that sick people ate much more frequently than the controls. And in this case, they really tracked it down to something very specific using 3 separate studies. First of all, they looked at the exposures of the case patients, the sick people, in a community just drawn from the population at large, and that allowed them to very quickly narrow it down to a restaurant. A specific restaurant that the case patients ate at far more frequently than the controls in the community. So then, using credit card receipts, among other things, they were able to identify healthy patrons who'd eaten at this restaurant and the sick patients in order to try to figure out what menu item it was. And that led them to realize that the patients had ordered a specific meat and cheese sandwich with a much higher frequency than the healthy restaurant patients. Finally, they dug into it even farther than that, and they put out radio broadcasts to try to find healthy restaurant patients who had eaten that very same sandwich. So then we had case patients and healthy people who'd eaten this sandwich, and they discovered that the controls tended to order the sandwich without the sauteed onions that came with it. So in this case, they were able to identify very specifically the part of the dish, a specific dish at the specific restaurant that was responsible for this botulism outbreak. They don't always investigate food outbreaks in this much detail, but it's an interesting model to look at. In each case, they had a case group, and they tried to find a control group that was as similar as possible to the case group in order to start to narrow down the source of the outbreak. When they have outbreaks caused by food that you buy in a store, as opposed to these restaurant outbreaks, these days they don't necessarily need to develop a new control group because they have done detailed diet surveys of what people eat. So if you have a case group that's getting sick, you can look at what they ate and compare it to knowledge about baseline diet in order to try to look for things out of the ordinary. There was one food poisoning outbreak caused by contaminated mangoes, where they were able to say that, look, these case patients are eating mangoes at a much, much higher rate than the general community, which suggests that, and indeed it was, the mangoes that are at fault. So those are sort of tools that people use to investigate outbreak. Next, I'd like you to watch the video that I've posted a link to on John Snow's investigation of the cholera outbreak in London. And while you're watching it, now, he didn't have any of this sort of vocabulary then, but I'd like you to think about his investigation and how what he was doing can be described as comparing sick patients to healthy patients in order to help him identify what exactly was the cause of cholera, which was unknown at that time. So there'll be another question for you on the form there.